Abhishek, I think we can get started.
Yeah, okay, Hari. I hope my screen is visible, my shared presentation.
Yes, go. Yeah.
Good afternoon, everyone. I am Abhishek Vijay and I head SciSec's academic programs focusing on skilling and promoting research. We'd like to welcome all of you to today's webinar, which is the fourth webinar as part of the Digital Defenders Masterclass and Capture the Flag Competition 2023. This competition is being organized by SciSec in association with Cisco Systems India Private Limited, Cisco CSR, and the Center for Networked Intelligence at the Department of Electrical Communication Engineering, Indian Institute of Science, Bangalore. We'd like to thank all of you for joining us. Let us now take a look at the schedule and how far we have progressed in terms of the webinars. So we are currently at the fourth webinar, and this is part of a two webinar series on the topic of web security. There will be a total of 8 webinars, all of which will be completed within this month. And the next two webinars will focus on the topic of forensics, and they will be held on June 20th and 23rd. We will be opening registrations for those webinars shortly. So if you have registered on the SciSec website, please watch your mailbox. And for those who have registered for the CTF, too, please watch your mailbox for the announcement for the next webinar. So I will very briefly go over the exciting prizes that are on offer for the participants of the Digital Defender CTF 2023. The icing on the cake is the internship opportunities at reputed organizations that the select top participants who perform very well in the CTF would be given a chance to try for. However, please note that this is solely at the discretion of the partner organization and that their decision in this regard will be final. There are also some exciting prizes on offer for the participants that total to a value of 4 lakh rupees. And I'm just going to go over the components once again. I've done this before, but I'm just doing it for the convenience of everyone. So there are three first prizes valued at 40,000 rupees, which have a cash component of 25,000 rupees, a Raspberry Pi, and a voucher for Hack the Box. There are five second prizes valued at 25,000 rupees, which have a 10,000 rupee cash component and a Raspberry Pi and a voucher for Hack the Box. And there are seven third prizes, which are valued at 15,000 rupees without a cash component, which comprise of a Raspberry Pi and a voucher for Hack the Box only. And in addition to this, we have 10 participation prizes, which are going to be basically Raspberry Pis. So the distribution of the prizes will happen only after suitable verification requirements are met by the participant. And the decision regarding the eligibility of an award for a prize lies solely at the discretion of the organizers, which too shall be final and binding. So we have now reached the 60th webinar in the Samgachadvam series. So last year, the government of Karnataka took a very exciting step by providing cybersecurity as a specialization option for the diploma students in the state. And we at SciSec helped to draft the syllabus for this course. Whilst we are sure it will be of assistance to the students who have opted for the specialization, we are confident that it will definitely help other students and working professionals who are interested in cybersecurity as well. Cybersecurity is not just a critical domain, but is also a complex topic. We will aim to provide an overview to each of these domains with the opportunities for conducting hands-on activities and with some pre or post read as may be required to help you to go into further depth. We hope that this will kindle your interest to explore further. The topic for today's webinar is web security and penetration testing, part 2. The next upcoming webinar is on forensics, which will be on Tuesday, 20th of June, which will be the fifth webinar as part of the Digital Defenders CTF Masterclass series. So I will now go over what I request you to please mute your mic, please. I will now go over the content, the gist of what today's webinar is going to be about. Web applications are the backbone of the world today. Many of the largest enterprises in the world, they depend on web applications as their primary source of revenue. Amazon is a very popular example. So this explosion has led to a large number of exposed web servers to the internet, and has also meant that attackers and bug bounty enthusiasts are looking at these servers as an entry point into an environment. So in today's webinar, Mr. Prapanch Ramamurthy, our speaker, will provide an overview of web applications on the internet and introduce some of the common technologies employed and showcase common attack techniques to infiltrate these systems and its users. We hope all the participants pay key attention to this, because these techniques would be very useful for you in performing well in the CTF, which would be the second stage of the competition. The talk will also include live demonstrations of tools and techniques using real examples of web applications. So we are planning to conduct the next webinar on the topic of forensics part 1 by Mr. Abhiram Kumar from Kroll Corporation. Please watch the schedule, and the registrations will open very shortly. Please keep watching the SciSec website for more such information. So you can access the previous webinars on the SciSec website as well as on our YouTube channel. I request all of you to please subscribe to our YouTube channel. It will help you to get to know when new recordings are out, and it will also help us in getting better traction and visibility. I'm just going to pause here for a moment and familiarize all of you with the different social media handles of SciSec. So you can find SciSec on Instagram, Twitter, Facebook, LinkedIn, YouTube, and Koo, and of course on the web. So on Instagram and Twitter, it will be at the rate SciSec COE. On Facebook, it's SciSec Car. On LinkedIn and YouTube, it's SciSec. And once again on Koo, it will be at the rate SciSec COE. I request you to please take a screenshot of these social media handles and to please like, share, subscribe, and follow them. I will now come to the scheme of today's webinar. So the speaker, Mr. Prapanch Ramamurthy, will first deliver the webinar, and this will be followed by Q&A. So by default, all of you will be on mute, but you can raise your hand, and we have our moderator, Mr. Kaushik, who will help you address your questions to the speaker. You can also type in your questions in the chat even as the webinar is going on. Mr. Kaushik will aggregate similar questions and call upon you if required when he addresses those to the speaker. But that will all be after completion of what the speaker has to deliver. Then there will be the link to the assessment, which will be provided after the completion of the webinar. And this assessment is going to be kept open for 24 hours post the webinar. And some of you might get some qualitative questions about webinar feedback. If you do, please answer them in all sincerity. So it's a Google form that is being used for the assessment. So you need a Gmail ID to access it. However, there is also an email field in the assessment in which you need to fill in your registered CTF or SciSec mail ID. That would be the only way for us to verify the users who would be scoring the respective marks in a particular assessment. So participants who get 10 or more answers correct out of 15 will be eligible for a certificate. So these certificates are planned to be dispatched by the end of this masterclass series. So those who think they've already scored 10 out of 15, congratulations to them, but we request you to please wait until the masterclass series is over, when we will collate all the data and dispatch the certificates to those who have qualified in the respective assessment. It is now time for me to introduce to you our speaker for today, Mr. Prapanch Ramamurthy. Prapanch is a principal engineer in Cisco's customer experience security team. As part of his daily duties, he focuses his attention on working with customers on solving some of their very challenging security problems and also comes up with innovative solutions and services. He is Cisco CCIE certified and also holds other certifications in the cloud domain. He has presented at various community, university, and industry events, including CommsNets, ACM, and is a Cisco Live Distinguished Speaker. He has a passion about spreading cybersecurity awareness in the community and volunteers his free time on solving the nation's security problems. So we are very happy to welcome Prapanch, and Prapanch, I think I can now stop sharing my screen and I'd request you to please share your presentation. Yeah.
Thanks a lot, Abhishek. Good afternoon, everyone. I see a sizable number of people, over 600 people that have joined. So welcome on this Friday afternoon/evening. I hope you all are eager to learn something new and also stand a chance to win something at the end of all of this, as Abhishek had just shown. So this is the fourth webinar in this series of Masterclass series that we're doing. And this is the second part of the web security / penetration testing session that we are holding right now. So I'm just going to share my application to start with. And I hope you all are seeing the screen there. Abhishek or Hari, if you can confirm.
Not yet. They're saying, yeah, now we
it's
can
visible.
see. Yeah.
Okay, perfect. Okay, so
I hope all the participants too can see Prapanch's presentation. Please confirm in the chat.
Yeah. Okay. So just getting started, first off, I'm just going to set this expectation that while I'm on video now, my laptop has the weird behavior of actually slowing down when I share my screen and have my video on as well. So I'm just going to go off of video for a short while just to make sure that you all can actually hear me clearly. And, rather than seeing, my face, which you can see now, but I'll keep that in mind for now for the rest of the session. And I'll come back on video at a later time. So just going off of video for now. Okay, so just to set some ground rules for today's session, I know a lot of you are using are using the chat menu to communicate. Do make sure that you're using the chat judiciously. It could be distracting for people, and use it only if you have a genuine problem so that we can actually look into it. If you have any questions, do use the Q&A panel, which is a separate panel. You will see at the bottom of your screen through a Q&A section. If you use the Q&A panel, you can actually ask the questions and we'll try and get those answered as and when time permits. But with that, let's get started. So I did have a slide that spoke about me, but since Abhishek has gone through all of it, I'll just skip right ahead and next part, which is talking at a high level about the agenda. So here is the agenda for today's session. We're starting with the introduction, which we just finished talking about the session itself. Then we will go into talking about the actual different techniques, or a little bit about the architecture, and the overview of what web applications look like, what's a server, what's a client, etc. And then finally, we'll go into the last few sections where we'll do actual practical hands-on things, talking about various attack techniques and tactics. A lot of this is meant to be introductory. For some of you, these may be things that you already know, but we appreciate your patience because this is meant to introduce the whole world to the concept of cybersecurity and penetration and offensive security in general. So with that, we'll get started with the second topic in this list, which is the architecture overview. So web applications, if you attended or seen the recording of the previous session that Karthik Sivakumar had taken, here are the top, sort of like at a high level, the two components that are involved with any application. So on one side is the server, which is actually hosting whatever the web application is. And on the other side, you have the client from where you and I, as users, will be accessing the application, right? So these are the two main components of a web application, right? Very, very high level. I'm not going into really the nitty-gritty details. And there's a request and a response, right? The client sends a request in most cases, and the server sends back a response. in response to the request that the client had sent. So whatever you need, the client, what you're asking through your browser, through your interactions, the server is returning back in response whatever you have asked for. Now, in the previous session, Karthik had spoken entirely about techniques, penetration testing techniques, specifically from a client's perspective. In this session, which is a part 2, we're going to look at techniques from the server's perspective. Okay? Now, while the client, which is yours and mine laptop, could be a computer, it could be a smartphone that we all use, it could be a tablet, or any other kind of client that we're using, is a single piece, right? Is a single piece of computer, and generally a single piece of software that you're trying to attack. In most cases, it's essentially through the browser that you're using in order to access the application, and your browser is the single component that you're looking to attack and exploit. When we're talking about a server, though, there are multiple components that come into picture, right? A server is generally comprised of many, many things that come together and eventually look like one single application, one single server. Like, for example, if you access Google or Amazon or Netflix or whatever web application you can think of, is not just one thing that's doing all the job. There's a lot of different components involved in this whole piece. So talking briefly about, at a high level, the 4 things that we are going to look to exploit today.
Yeah, Prapanch, sorry to interrupt you. Just one clarification. You have shared the application, or I mean, you have shared your screen or you have shared the application?
I shared my application.
Yeah, okay, fine.
If it's not visible, I can try and share it in my screen if you would like.
No, I think Karthik had the same problem, na? So that's why shared the PPT. So because some people in the chat are saying that it wasn't visible, so that is why.
Okay. Yeah, if you're on your phone and you're not able to see it, do let us know. We'll try and see. Or if someone's on the phone and they can see it and can confirm, that will be helpful.
Yeah, okay, it's visible, it seems. All right. Yeah, thank you.
Okay, sure, no problem. Sorry, just getting this out of the way. Yeah. So on the server side, you have these 4 broad components that we're going to talk about when we're going to exploit a server. The first is essentially the web service itself, right? A lot of you are probably from the computer science, IT background. Even if not, you're all users of a computer on a day-to-day basis to do projects or to watch movies or to do anything that you're doing these days. Everything happens through a computer. And a computer essentially is a bunch of different services that come together to deliver, whatever is happening on a computer. Similarly, on the web server side, you have a service that the client will front end interact with, and that service essentially is giving back to the client whatever it needs. It's the interface that the client works with in order to get data back from the server or submit data to the server itself. So that's the web service part. The second part of the component that we're looking at is the file system. Now, the file system, it could be potentially file system on the server itself, right? It could hold different kinds of files, files that contain, let's say, the actual HTML or the JavaScript or the CSS source code that Karthik spoke about in the previous session, or a bunch of different things from file perspective. Could hold sensitive data, such as potentially username and passwords, if you chose to do so, and could actually be storing user-specific information as well in terms of what the user is submitting. Could be Word files, could be PDFs, etc., etc. And all of that is a file system. So a web service very often, or 100% of the times in most cases, actually has a file system that's backing it. And that file system is another area where one can actually kind of go and inject or infect the system, a web server. The third component in this that we're going to look at is database. Database are basically, storage components for storing persistent or transient data that the web server can actually query and return back information to the user. And there are various kinds of purposes that databases solve. You all have probably heard of databases, and we'll come to that in a little bit when we go towards how you actually exploit databases. And finally, you have other services, and mainly external services. What you see here right now might look like everything is within the same server, but you might actually have multiple other servers and services as well that you might talk to. Right? If you're talking to, let's say a streaming service that's streaming audio or streaming video, you might see ads that are coming from a different component altogether. So it's not held directly on the server that you're talking to, but it's actually coming from a third party in that case. So there are different third-party integrations that happen, such as APIs, etc. So we look at some of that in a little bit more detail. So we're going to broadly break this up into two components. But before we look at that, what is the reason why we're looking at all of this? It's important to understand that because a server, a web environment, a web server is comprised of all of these different components, it leads to what we call an increase in the overall attack surface of what an attacker or a bug bounty enthusiast could actually exploit for their personal gains, right? So an attack surface, the definition as you see on the screen, is essentially the sum of the different points in a system where a user such as you or me or someone with a malicious intent like an attacker can try to enter data or extract data from an environment. So if you think of, in the previous picture, we had a client. A client is a single piece, in most cases just the browser. So your attack surface is limited to mainly just the computer and the browser that the user is using to access a website. But on the server, your attack surface is much larger because now you have the web service, you have the file system, you have the database, and you have any number of other external services that a server might talk to. And all of those contributes to an increased potential attack surface. So the good news, as someone who's looking to exploit a system, is basically that there's a lot more that one can do as opposed to when one's trying to exploit the client. So this is the concept of attack surface that's really important to understand. Now we'll broadly look at these attack surface or these components in two different parts and sections. The first is the backend technologies. Like I said, the web service is what the client interacts with, and that acts like the middleware, right? That is what I'm referring to as the backend technologies, essentially. And it basically focuses on the graphical and user experience aspects of the website or the application. So the main purpose of these backend technologies is to act as the middleman, right? It's sort of like the person delivering, your delivery packages from Amazon or Flipkart or wherever, right? It's sort of like a courier service in between, where the client requests something from the server. This courier service is checking where the data is and returning it back to the client. So your backend technologies oftentimes are the ones that are taking care of basically interfacing between the client and other sources of data in the background. And this is typically the only directly user accessible part of the web application. And the key word over there is typically, because oftentimes you will see servers and services are misconfigured or are exposed out to the internet. And so you can actually access not just the web service, but also the database as well, or potentially the file system as well, as you will see using some examples as we look through in the next few slides. So what are some examples of backend technologies that one might use? If you are from a computer science background or someone who writes codes or a script kiddie, you would have heard of some of these in the past. So you have PHP as a language. JavaScript is also something that could be used on a server. We did talk about JavaScript from a client side, but even server side, you have JavaScript code potentially that can serve web application data. You could have Python, Java, Golang, but this is only a very small subset that you're looking at over here. The actual list can be infinite. You have many numbers of such backend technologies that can be used to render the web application and act as the middle interface between the client and the source of the data that the client is requesting for. So we spoke about other services that might be part of the web server architecture, right? And on the slide, you see that over here at the bottom in the square. And there are many different kinds of services that a web server might interact with. And mainly all of these are designed in such a way that the user doesn't actually get to see what are these various services. But from an attacker's perspective, it's important to really understand what are these various services, what are the purposes that they solve, and how a server actually interacts with these services so that you can potentially exploit them and get data out of it. So some of the examples of such external services are the most famous one, databases. Databases are persistent or transient storage of data. You might be storing user information, session information, configuration data. If you're working with, let's say, an e-commerce website, such as Amazon, they may be storing all of their product catalog in a central database somewhere. So database is essentially used to store data in that format, in a structured format, but it makes it easier for the server to query that. At the same time, if that database is not clearly secured and the communication between the server and the database is not securely maintained, an attacker can actually exploit that. And we'll look at a few techniques later. You have APIs, which is application programming interfaces that a server might talk to. You could also have user authentication services. For instance, if you're trying to log into a new potential system, let's say you try to log into some new application that's out there that you've downloaded for your smartphone, you would generally see some options such as login using Facebook, login using Google, login using LinkedIn, etc., etc. Now, how does that actually work, right? Now, in the background, there's a lot that happens, but a key part of the system that actually servers use are basically APIs. So a server will talk to Google and Yahoo or Facebook and LinkedIn or whoever that might be that you are using to log in with, and they'll use these APIs to communicate with them in order to try and authenticate you. So authentication is another key component. And as you can see, when you're talking about authentication, that becomes very, very critical and sensitive, because when you talk authentication, you're talking usernames and passwords. And we all know how critical it is to secure one's username and password. So all of these are other external services. And as you can see, this list can keep growing. It probably isn't just one or two things that a server is talking to externally. It might be talking to many hundreds of different services. And all of these essentially contributes to an increased attack surface, like we discussed earlier. Again, attack surface is the really key operative word when you're talking about exploiting, web servers, because you're talking about a lot of different components coming together to deliver to you one single application. Okay, so now we're going to start looking at a few tools. Again, I'll just start sharing my browser as well. So the first tool we're going to look at is what is basically the browser inspector. I hope you all are seeing the browser. You can see the PicoGym web window. Abhishek or Hari, if you can confirm that.
Yeah, we can see the PicoGym web window.
Okay, perfect, awesome. So we're going to look at browser inspector. Now, I think a little bit of it was actually spoken about in the previous session as well, but what we're going to do is we're going to look at it in a little bit more detail and talk about some of the components that are part of this. So how do you access the browser inspector? First, I'm going to just open, one potential, web server website using this practice challenge that we have here. So this is a web server that I'm going to open. So it's open here. So let's say this is any web server that you're using. It could potentially be Amazon, Netflix, any web server that you're accessing whatsoever. For all of those, you can actually use the browser inspector to actually inspect what your browser is doing when it's talking to the server, and also what is the server returning back as data. So let's look at an example over here. So what I did was right click over here and clicked on this option called inspect. There are other ways that you can access that. For instance, I'm using Firefox, but every browser has this. If you're using Chrome or Edge or any other browser, you should be able to get access to this. So you can go to the developer tools over here and you can get to the inspector even from there. So what does an inspector look like? So this is what the browser inspector actually looks like. So you see there's a lot of data available here. All of this talking about essentially whatever the client has received from the server when it sends the request over. So what you see in this very first page, again, the font might not be entirely clear, but essentially what you see here is the actual source code of what is rendered on your browser. So if I look at what's in this and open this up all the way around, in the browser page, you can see there are a couple of buttons that says choose red and choose blue. How do they get displayed? Is through something called HTML. Again, Karthik spoke about it in the last section, but you can actually see what they are over here. What does the actual HTML source code look like? And this is a really good source of information because you can actually get hints about what's in the server. There's already a hint visible here just based on this HTML inspector, which you can't actually visibly see, which is what is the backend technology being used to render this web page to you as a user. You can see here this file called index.php, which should automatically, as an attacker, what that tells them is the fact that PHP is being used here in order to take in scripts written in the PHP language and render it as a web web page to the end user. So now you're immediately thinking about, okay, they're using PHP. How can I exploit PHP? What are some options available to me, etc., etc. So this is the default inspector view where you get to see the source code of whatever the page is. Apart from this, you have a bunch of other data as well in this browser inspector. So you have the console. Console is sort of like the place where you can see all the messages that have been printed, any error messages, any logs, etc., etc. All of them get dumped over here. But we're not going to look at that in detail. Again, Karthik spoke about this in a little bit. We're talking about basically JavaScript over here. So any JavaScript that this page uses, you can actually interact with it using this debugger. And you can actually see what data is being used, what functions are being called. Is there any critical information saved here? All of that should be visible in this debugger menu. You have the style editor, which is talking about CSS, which is where you're using things like how should the web page be designed, what color should it have, what should the buttons look like, what should a form look like. All of that is done using the CSS. And you have a bunch of other data. For me, the most important thing is this network tab, right? In the last session, Karthik had spoken about Burp Suite. He'd shown you how Burp Suite works and how you can actually intercept web traffic from your PC, from your client over to the server, and actually see what all is being sent and received. This is very similar to what Burp Suite does. Burp Suite obviously has a lot more capabilities, but over here you can actually get the same information that Burp Suite shows you based on whatever interception it does of the client and the server request. So what I'm going to do is just quickly reload the page at the background, and immediately I can see what requests my client has sent and what responses are coming back from the server. So you can see here from an HTTP perspective, this is a GET request that's being sent to this domain. You see the domain matches with the address bar over there, mercury.picoctf.net. And if you actually click that, you will see all the headers that are part of it, right? What were the request headers? You see them over here. Whatever were the response headers, you see them over here. And you have a bunch of other data as well. You have cookies. You can see the actual request, any payload that was sent in the pay request, and any responses that came back. You see it's literally the same. The response in the browser and the response in this tab is the same. You can still see the raw HTML code if you wanted to, even from here, right? And similarly, you have a second request, but you can see this was a GET request sent to some retrieve a file called a favicon ICO, but then it returns back a 404 not found code, right? But again, you see the request headers, response headers, etc. So immediately you can actually see a lot about what's happening with this website. And what else can you see here, right? You can actually see, like I said, previously you already saw PHP index.php. If you had missed it over there, you actually have a hint over here as well, based on just the cookie name. It says PHP session ID. Again, another hint that PHP is being used as a backend technology. So you get a lot of hints, right? Right now, what you're doing is collecting hints, and the browser inspector is a great tool to give you all of these hints to understand what's going on. Not just that, right? Not just collecting hints, but let's look at this challenge itself. And we are doing all of this for the purpose of a CTF at the end. So here is basically the challenge description that I just did, that I just showed you. The challenge is find the flag being held on this server to get ahead of the competition. This is how all the CTF challenges will be. Regarding of what category you're looking at, be it web, forensics, network security, cryptography. At the end of the day, you're looking for a flag, and the flag has to be in this format, which is PicoCTF, curly brackets in flag, right? So there'll be some format of the flag that you're looking for. Now, how can you actually get this over here? Now, if you're somewhat familiar with how HTTP works, you have a hint in just the heading of this challenge, which is get ahead, right? So what it is essentially, there are different ways in which you can interact with the web server. You can send different kinds of requests. Yeah.
Yeah, Prapanch, your audio just broke.
Okay. Is it audible now?
Yeah.
Okay. How long was it not audible for?
About half a minute, I think.
Half a minute. Okay. So I'll just talk about the challenge specifically.
Yeah,
so,
yeah.
So this is the challenge that I was talking about. So your objective is essentially to find a flag hidden somewhere as part of this challenge. In this case, it's a website. And from the website, you're supposed to extract a flag. And the flag will have a specific format based on the kind of CTF challenge that you're participating in. So here, the format of the flag is mentioned here. Now, if you're familiar with HTTP somewhat, the hint is actually in the challenge somewhere in most cases. So in this case, you see that the challenge name is get ahead. Head basically is a different kind of request that you can send in HTTP. So I'm bringing back the inspector over here just to show you. So here's the inspector. So you see the method is get. You have different kinds of method that you can use. Head, post, put, patch, delete, etc., etc. Different kinds of methods that HTTP allows you to do. So the hint over there was potentially to send a head request. Now, how do you do that? Right? Let's say you've come to this challenge and you see that, okay, I want to try and send a request with the method instead of get. I want to send a head request, and maybe that will give me the flag. You might be wondering what's the easiest way to do that. There are a few ways you can do that. The simplest way is to do that actually is directly using the browser inspector itself, right? So here's the request that I want to take, and I want to just modify one thing in this, which is instead of get, I want to change it to head. So this is how you can do that. So in Firefox, there's the ability to edit and resend a request. So I'm just going to click that, and you'll see a small window open up where I can change various parameters of the request itself. So you see the URL over here, you see a bunch of headers that you can modify and change if you wanted to. But what we want to change for this challenge is this over here. So these are the various options available, the kind of methods you can choose. I'm going to choose head, and I'm going to send the request by clicking this button at the bottom over here. So I've sent it. So you can see this request over here. Let me collapse this. So the request over here is now a head request sent to the same server. Now, again, you see the bunch of headers. You see the request, you see the response, everything. But if you pay close attention, you already have a flag over here, right? So within the browser inspector, right, all of this, what I just did, understanding what the server does, what the challenge is about, editing and resending the request is all possible within the browser itself. So if I just take this flag, I copy the value and I put it over here, I should be able to basically solve the challenge, as you can see. So this is going to be a very useful tool, right? You have other options as well. Like for instance, from within the same page, you can actually see the source code of the content as well without going to the inspector. Right click and say view source, and you see the same HTML, HTML, JavaScript, CSS, everything over here. And you can actually click through and follow anything you want to see. So if you wanted to see the actual CSS, click on it, you will see the actual CSS code. Now, I'm not in favor of this because over here, it's like looking at a raw text file. The better tool to use really is in most cases, the default browser inspector, where you can do a lot more. Okay, so coming back to the PPT, just gonna swap this place. Oh, sorry, did I swap this place? Yeah, so you should be seeing my PPT now. So that was a quick demo of browser inspector, and we'll keep coming back to that again and again while we're doing more challenges and techniques and tips that I'll show you going forward. So moving on, right? It's time for a change in gears. So we've done with the web architecture. Now we're going to look at individual actual attack techniques. Before we do that, I'm in the habit of actually using stories, somewhat relatable stories, in order to be able to relate back to what technical content is being said. Okay, and the story I'm going to use here is one of an airport. So most of you have probably had an experience in an airport at some point of time. Even if you've not, you've seen in movies and TV shows and wherever, right? You've seen evidence of what actually goes on in an airport. So you'll be able to hopefully follow along what I'm trying to say. So if you're like me, and if you've ever traveled in an airline, you've probably only traveled economy class before, right? So what do you do when you go into an airport? You reach the airport, you show them the ticket that you have, you go to the counter, and you actually get your boarding pass based on the ticket that you bought. And the boarding pass contains essentially your flight number, your seat number, your details about when the flight's going to take off and which gate it is in, etc., etc. And it also tells you which class you belong to, right? The economy class, for instance. So that boarding card you take, and then you go into the security area. And immediately when you go to the security area, you're probably going to see that based on the class of travel that you have, if you're economy, you go into one line. And if you're a business or a first class passenger, you go into a different line, right? So based on that one tag in your ticket, you're being treated differently. right? When you go into an airport. So now you do that, you finish off security. Generally, you have a long queue, and then you move out, and then you go into the actual terminal area, and then you go look at restaurants and lounges, etc., etc. And over there again, you see something similar. You see that there's lounges that are dedicated for business class and first class. I've never seen the inside of it, but for me, I have a picture where it looks really luxurious, and the food and everything else tastes very good. But then if you go to the economy class and if you go to the lounge, it's a different experience, right? So that's again a place where just based on that one tag, you're doing things differently. Again, when it comes to boarding the aircraft, your business and first class passengers would board first, your economy is next, right? So you see that based on the class that's in your ticket, things are handled differently. So that will set the context for what we're going to talk about next, which is basically session elevation based on cookies, right? Karthik has already spoken about what cookies are, but I'll just give a very short introduction about a cookie and what the purpose is it serves. So cookie essentially is a very small piece of data, extremely small, a few bytes in most cases, that is created by the web server, but is actually stored on your client, right? So it's created by the web server, but it's stored on the client, and it's used for various kinds of purposes. Just like on the ticket you had your economy class, the cookie is doing the same thing for you. It's doing various things such as tracking your behavior, right? If you click on a particular link and from there you go on to a different part of the web page and then to a different part of the web page, it's able to track, the web server is able to track all that you're doing on the website based on the cookie, very small piece of data that's stored. It might also be used for advertisements or for authentication and session management, which is where the problem comes, right? The most critical aspect comes. So now, Abhishek had spoken about why we are looking at web applications and how they are the most important source of revenue. So this sort of slide gives you an idea about how cookies are really used by web servers and applications to generate revenue, right? Get money. You all have seen ads, right? You might be, in your phone, you might be thinking that, okay, I saw something interesting. I heard about something interesting on a TV, or my friend told me about this cool new thing. Let me just search about that, right? It might be, let's say, a new kind of noise cancellation earphones. So you just search for that on Google or whatever application that you have, right? And the moment you search for that, you start seeing that regardless of what website you go to, you're only seeing ads about headphones, noise cancellation, audio systems, etc., etc. It's as if someone's actually listening into what you're doing or actually looking at your browser from over your shoulder, and they're able to see what you're searching for. And based on that, they're delivering ads to you so that you actually are more likely to click on what's actually being presented. So how does that actually work? The magic of all of that is in cookies, right? Anytime you visit a website, they are not only tracking what you're doing, they're actually sending back a cookie with a unique ID, a very small piece of data, right? For illustration's sake, let's think the cookie is 123, right? Now that data 123 is stored on your browser, and regardless of any website that you go to, that data is stored on your browser and it's constantly sent back to the server saying cookie value is 123, which is the step 3 you see over here. So every time the cookie value of 123 is sent, this third website, b.com in this case, is asking the original website, a.com, this is a cookie I got from this user called 123. Tell me what kind of ads I should be sending them. And that's where the original website tells you that, hey, the kind of ads that you should be sending them is for, an audio cancellation headset or, whatever. So this is essentially the concept of how cookies work. So, and this is actually how companies make money, right? How does Google make money? Not through their search engine, because that's for free, but they make money through giving out this data about what users are browsing, right? Potentially, and serving ads to you based on the data about what users are browsing. So the same holds true for a lot of web application-based companies today. So one of the things that I said was, cookies are also used for storing critical data at times, such as user information, right? Such as, what is a user authorized to do on a web server, right? Which parts of a website is a user allowed to access? Remember, going back to the boarding pass, economy class, that one small cookie is actually telling everyone in the airport and the terminal what you're allowed to do, right? Where you're allowed to go. Similarly, the cookie does the same thing, right? Now, that is where problems happen, is if the cookie is not secured well enough in the form of encrypting it and hiding it from the end user, a user could potentially modify the cookie and get elevated access. Going back to the airport example, imagine someone being able to print their own boarding pass which said business class, and that actually allowing you to go everywhere in the airport. Now, obviously, that's not possible unless you actually figure out the QR code and scanner and how all of that works. It's obviously well secured and well encrypted, but the parallel you can draw is that. Right? Imagine printing your own boarding pass which said business class. Now you have access to other pieces or other sections of the airport and the terminal and the flight that you would not have had access to if you were carrying an economy class boarding pass. So that's how session hijacking or session not hijack, session elevation works with the help of cookies. And why you should care is because this is actually a good way to make money. I read about this article a couple of years ago. Right, one of the bug bounty hunters from India actually made what I think $100,000 US dollars, which is what, about 70-80 lakh rupees, because they found a vulnerability in Apple in the way they were sending back cookies and how someone could modify it and get access to other people's data. So that's how simple it looks, but it's difficult to find these vulnerabilities. So let's look at one such example, right? We're going to look at another challenge. And this time it's called Power Cookie. So I'm just going to go here. Search for that. Power Cookie. So let's go to this website, right? So it says here, can you get the flag? Go to this website and see what you can discover. Again, if you just look at the challenge itself, you get an idea that this has something to do with cookies. So we'll go to this website, see what's in there. Yeah, it looks like, just a simple web page, not a lot in here. Now, again, we'll go to the browser inspector again, because like I said, that's going to be what I'm going to use a lot today in this session to show you what you can do with a simple tool such as just the browser inspector. Okay. So click on inspect, open the browser inspector. Once again, I get to see information about what this server is. Looks very simple. It has one simple JavaScript over here and very little content in it. It's just a button and it's calling a function here. Okay. Now, if I want to actually see what the JavaScript does, guest.js, like I said, you can go into the debugger tab. And if you see guest.js, you see what it does. If you're familiar with JavaScript, you would understand what this function does. If not, you could just search online or ask ChatGPT, pass the JavaScript function to it, and it will give you exactly what this JavaScript function is doing. So, like I said, my favorite tab is the network tab, which I'm going to go to. And I'm just going to quickly reload the page. So this is the request. These are the various requests that were sent to the web server. And this is the first request that we're looking at. So again, the GET request sent to a particular domain, basically retrieve the request of the contents. You see a bunch of request headers and response headers. And in this, you can see a lot of data. Similarly, you can see the request and response. And you can actually see the cookies as well. Okay. So cookies here, like I said, is a very small piece of data sent by the server and stored on the client, right? And it is sent along with every request that the client sends. So you can actually see the cookies here in this tab. And this is the name of the cookie. It's admin. And the value of the cookie in this case is the string 0. Okay. So you can actually see this as part of the request headers as well. You see here cookie, name is admin, the value here is 0. So something interesting, right? Now, what could it be, right? What could we do? Could we modify the cookie and resend this request and get the flag? Yes, potentially you could, right? You could potentially modify the request and send it back to the server and see what you get back. Now, in this case, the cookie is actually very simple. All that it is doing is the value is 0. Now, to any normal person, you would think that just looking by the name, it's saying is admin and the value is 0. You would think that maybe setting it to 1, you will get something, right? So, okay, that's what we want to do. So let's try the same thing that we did last time, edit and resend. Now, this is not possible to modify using the actual browser inspector itself. So you can see the cookies can't be modified in the browser. And this is just a way for the browser to protect against such session elevation attacks, right? They do not want end users to play around with cookies and potentially get access to data that they are not supposed to have access to. So I can't modify the cookie from within the browser and actually, see what kind of data is coming back. So what can I do? Well, the good thing is you can actually copy this request in various formats, right? So you can see here, you can copy this request as various scripts. For instance, you have curl, you have PowerShell, you have different other ways as well. For me, what I like is curl because I'm on a Mac. And for me, curl is a default utility. So what is curl? Curl essentially is to be able to query any website or a URL from the command line interface, right? From a terminal window on a Linux or a Unix-based system. So what I'm going to copy this entire request, I'm going to copy it as curl, and I'm going to try and replay it to see what happens. So let's try to share that as well. I'm going to bring it over here. Okay. So this is my terminal. I'm just going to try and make it bigger so you all can see it. So this is a terminal that I'm working with. Now, I've already copied the request as curl. So what I need to do is right click and paste. And you can see this is the curl request that's being sent, right? Now it looks very complicated, very fancy, but don't really worry about it. Let's clear the screen out. Okay, paste it again. So don't really worry about all that you see here. It's basically everything that you see in the request, right? You saw the URL, that you saw a bunch of different request headers. All of that is sent here. But what you also see here is the cookie, right? Cookie is admin equal to 0. And if I just send this request as it is, it's going to get me the data back. Now, in this case, it's binary data, so you can't see it, but we'll do that later. What I wanted to do actually was modify the cookie, right? We said is admin equal to 0. Maybe we change it to 1 and we get something else back in this. This is a very simple, very, very basic example, but that's how session hijacking works, is being able to modify a cookie, breaking its encryption and making the server trust as if the cookie is that way. So I'm going to do that. I'm going to send this request over to the server, set it to 1. Okay, so it's binary output, as you can see here, right? So it's not actually able to display it on the screen. So what I'm going to do is save this to a file. Okay, cookie.zip. Actually, just cookie. Okay. So now if I look at the file, so this is the file that I received just now, right? So I've now saved the request, the response that came back from the server over here, right? Now, basically your next job is to try and find out how you can open the file, right? So you can try to open it directly, but it may not work. You may try to, you first want to find out what kind of file it is, right? So it says it's a binary file. So you want to see, what kind of file it is and how do you do that? So the good thing is Linux has this, again, default utility called file. And you can pass any file to it and it'll tell you what kind of file it is, right? So I sent this command file, the name of the file to the command called file, and it tells me what kind of file it is. So it's telling me that this is a gzip compressed file. So if I just rename this file and extract it, hopefully I'll get something else from it. So again, I'm just going through this a little bit fast because this is not the context of what we're doing in terms of web security. But what I did was change the file name to cookie.gz because this is a gzip file. And now I'm going to extract it using this command, right? And now if I look at what is here, and there's this file, again, I look at it and it says it's an HTML file now, okay? And now if I open this file, sorry, it tells me exactly what has been returned as part of the HTML file, right? So this is how you can actually interact with this. I can actually open this file in a browser as well if I wanted to. but I don't want to really go that far right now. But this is how easy it is to basically manipulate any cookie and try and get to the data that you want to, right? Again, cookies are meant for different kinds of purposes. Not always, meant to actually store critical data, but sometimes cookies can actually be used to store critical data. And if a cookie is used to store critical data in terms of, are you economy class or business class? If you're able to change that and make the server trust that what you're sending is the right data, then you're able to actually get access to things that you previously did not have access to. Could be a flag in a CTF tournament, but in a real server and a web applications case, it could be critical data of another user who you as a user should not have access to. So cookies can also be encoded. You can encode it in different formats, and it all comes down to really understanding what kind of encoding is used. And when you encode it, generally there's an easy way to decode it if you just paste it online. And the hint to actually the kind of encoding is actually in the format of the string. And base64 and JSON web tokens and all of those use a dedicated format of encoding when they're talking about cookies. So this was the concept of session elevation, right? Using cookies. So if you have cookies, and if you're looking to actually play around with them, your tips are essentially understand what the cookie holds. If it is clear text, you'll be able to see what directly it is, just like is admin. If it is not clear text and if it is encoded, you can do a quick search online to understand what kind of encoding it is, decode the cookie, and then be able to actually modify it and play around with it. So that was the first part of the presentation. I'm going to take a quick pause and see if there's any questions related to the content over here in any of the chat windows. Or
No, so far.
none so far. Okay, cool. Yeah, if there's any questions, do post them in the Q&A window, and we'll try and get those answered at the earliest possible. Okay, so that was first. We were talking about session hijack, right? Now, continuing the example of the airport itself. Now, regardless of what kind of boarding pass you have, be it economy, business class, first class, etc., there are certain sections of the airport or the terminal you're not allowed to enter whatsoever, right? Like for instance, accessing the actual runway or other sections where baggage is handled, right? Those are areas that as a user, you're not supposed to go to whatsoever. That is only meant for those people that have the authority to do so, right? Not meant for users of the website, right? Similarly, on a website, you have sections of the web page that users can access, right? You can be a user and come in there, but there are certain sections of the web server itself which are beyond the website's control that you as a user should never be able to access. So let's look at what are some examples over there. So this is where we talk about the concept of the web root, right? So the web root in context of a web server is the topmost directory or folder in which the files making up a website are stored. What are the files making up a website? They would be HTML files, they would be JavaScript files, they would be CSS, there could be PHP scripts, or different kinds of these files, right? All of these files that make up a website are stored under one folder, and the top level folder, the extreme top folder under which all of those files and other folders exist is called the web root, right? So here's an example. Let's say this is a web server, right? Typically, if it's a Linux-based system, if you're installing Apache or any server on it, your web root generally is /var/www/html, under which you would have various kinds of files, right? And you could also have folders. So your web root essentially in this case is /var/www/html. And as users accessing the web server, you are allowed to access everything that's under this web root, depending on your privilege level. For example, in this case, admin.php might only be accessible to the administrators, right? It may not be accessible to you as a user, but only to the actual administrator of the website. So regardless, from a website, you can only access everything that's under a web root, right? But is that all that's there within a server? The answer is no. You have a lot of other places within a server where data exists, right? And in some cases, extremely sensitive data. I'm talking specifically about Linux here, but the same applies to Windows or any other operating system, right? So can you actually go beyond this web root and access data that's available in other parts of the system and actually extract that and take a look at what's in there? And what if that is sensitive data in the form of user passwords or configuration files or any other sensitive data that might exist? So going back to the analogy of the airport, again, a cookie or whatever that may be, a web browser should not give you access to data that is beyond the web root, right? Beyond the terminal. But if you are actually able to get there, then you're actually getting access to sensitive data, right? So how do you do that, right? Now, there are different techniques available to actually do this kind of attack. The first one is called local file inclusion. Okay? What is local file inclusion? It's basically tricking, again, you're cheating in a way, the web server, the web application, into exposing or running files on the web server that a user should not have access to, right? For instance, directory traversal is one of the most, common and, easily understandable kind of attacks when it comes to local file inclusion. So what are you doing with local file inclusion? Again, you have the web root where www.html, and you have files and folders under that anyway any user of the website has access to. But previously, you did not have access to sensitive data that were not under the web root. Local file inclusion is a way to trick the web server into giving you data that is outside of the web root. So basically, instead of index.html, you can get access to passwords, you can get access to configuration files, etc., which are extremely sensitive. So this is local file inclusion, right? And like I said, one of the very common ways of doing this and the simplest ways of doing this is directory traversal attacks. What is directory traversal, right? So over here you have /var/www/html. So directory traversal is basically going past this web root and going one folder above at a time and seeing how far you can get to actually get to the data, right? So over here, you are going 3 levels up, right? As opposed to /var, you're going into /etc to get data, right? So that is directory traversal. And again, not all websites are vulnerable to it, but we'll look at an example of how that you can explore this. So again, instead of looking at just slides and core, we'll look at actually a challenge and see how that might be possible. So this time the challenge we're going to look at is called forbidden paths. So go back to Pico CTF. Okay, I'm just going to search. So this is a challenge over here, forbidden paths. Okay. So again, you have a website, and here's the explanation of the challenge: is can you get the flag in this website? So you know that the website files live in user share nginx HTML. What that means, if the website file lives here, this is the web root, right? So everything that you're using to access the website is under this folder. And the flag is located as /flag.txt. But the website is filtering absolute file paths. Can you get past the filter to read the flag? Okay. So your objective in this challenge is simple, right? Is what you're accessing will be under this folder. You need to get to this file somehow. How can you do that? So let's look at this website again. So here I've opened the website. So what it looks like this website is doing is under the website, you have, this is a folder that you're in. So again, we'll look at what the folder was: user share nginx HTML. And under that, you have these text files. And this is a web reader. That means you should be able to open any of these text files and see what's in. So let's try and open the first one, which is divine.comedy.text. Great. So it's giving me whatever are the contents of that text file, right? It looks like either an essay or a poem or whatever that may be. Okay. What else? There's another file, olivertwist.txt, right? Great, I can see that as well, right? So basically, what this website is doing is it has an input field here. You can enter a file name, and it will actually return the contents of the file if it's able to access it, right? Now, the objective of the challenge is to get to this file called flag.txt. Let's try that and see what happens. We know it will not work because the challenge already says so. So if you just go to /flag.txt, you say not authorized, right? So it's not allowing you to go to /flag.txt directly, but the hint is in the challenge itself that it is filtering absolute file paths. What does that mean? There's two kinds of file paths in a Linux-based subsystem. You have absolute file paths and you have relative file paths. Okay. So I don't have an image showing it, but I'll just show that from my terminal. Okay. So this is the folder that I'm in my machine right now. So it is /users /PRA/PRA/MA/downloads. Okay. Now, absolute file paths basically are named like this. So /users /praprama /download / whatever text file, right? Just like /flag.txt. But relative file paths are, you can actually maneuver to different folders by doing, so if I do ls-l, you see I can see whatever is in my current folder, right? But what I can also do is ls-l of ... And what ... is basically is a relative file path. Relative file path is this ... means compared to the folder that I'm in right now, go one folder up. So as opposed to downloads, remember we were in users PRA/PRA/MA downloads. If you do ls-l ... it's telling the operating system that it needs data from one folder up. So it will give us data from users PRA/PRA/MA, this location. And you'll see the files are different, right? Let's try it twice again. Clear this. ls-l, we'll do two ... And now you're getting data from /users, right? And if you do three, you get data from absolute root /, right? So you can see this is a relative file path, right? ... is essentially a way to go one level up in Linux-based systems. So coming back to the challenge over here, you cannot go to /flag.txt, but can you use any relative file paths to get there? Remember, the folder we are in is user share nginx HTML. We need to go 4 levels up to get to flag.txt. So you need to go from HTML to nginx, from nginx to share, from share to user, and then go to flag.txt. So that means you need 4 pairs of dots, right? Let's do that. So we're just going to do ... /... Now I'm at the root based on the relative file path. And now I'll do flag.txt. And this is giving me the actual contents of the file. So you couldn't get to it just doing /flag, but you're able to get to it doing relative paths. So this is an example of directory traversal, right? So you're by default accessing everything that's under the web root, which is user share nginx HTML. But by tricking the website, you are actually able to get data that's beyond the web root and able to get data that's stored in the actual root of the folder or the server, which is flag.txt. So this is the concept of directory traversal. There are different ways, again, in which this can be done. You can actually have some kind of encoding techniques as well. But the basic premise of what I meant to show you here is the concept of what local file inclusion and directory traversal looks like. Okay, so moving on to the next technique. So we've seen 2 techniques now. We've seen session elevation by modifying cookies using the browser inspector and curl. And we just saw how you can extract data from a server beyond what's in the web root and get to potentially sensitive files, right? Actually, if you want to try that, we know this was Linux-based server, and one of the critical files in any Linux server is /etc/tasswd password. And this contains all the users of the system, data about their privilege levels, and all the folders they have access to. So you can see, so not only do I get access to the flag, but actually I can get to other sensitive parts of the system as well, right? Here's another one, etc sudo. Okay, it's not there on this. Shadow, can get to that. No, there's no such file, or maybe it's empty, right? So you can see that I'm able to get to other sensitive parts of the system because of the vulnerability left open here. So that was the second technique that we've seen. So moving on, just within the context of getting past the barrier, we're going to look at something called remote code execution. Okay? What we saw previously was local file inclusion. Again, local file inclusion is taking the web server into giving you data that is beyond the web root. Now we're going to look at remote code execution, right? RCE. What is remote code execution attacks? Is basically being able to execute arbitrary commands, like for instance, ls-l, and seeing what are the contents of the folder, or being able to read the contents of a file, or being able to create a new file. Any arbitrary command that you can think of on the web server. So that is remote code execution. Basically executing code on the web server by taking the web server, by sending it custom data. Now, I've actually seen many examples of remote code execution. All of you are, I don't know if you're at home or in your hostels or colleges, but if you're at home, you're probably accessing the internet through a small internet router. Something like this. If you try and access the web server that's running on the router, you will probably get to a page that looks somewhat similar. Okay. Now, what's in the router essentially is a bunch of its configuration, right? This is actually a screenshot of my router, right, at home. And you'll generally be able to manage the router, see if there are any problems, change any configurations, etc. And if you don't have internet, right, generally you're calling the ISP and checking why you don't have internet. Guys, can you hear me?
Yeah, you're audible.
Okay, I saw a notification saying my internet was slow, so I just wanted to make sure that. Yeah, so you can, if you're having trouble with accessing the internet, you would actually have some utilities to troubleshoot why you're not able to access the internet. You can ping, let's say, from your PC to the internet to see if it's working. You can actually ping from the router, in most cases, to the internet to see the router can reach the internet or not, right? So in this case, this page that I'm showing you here right now is exactly that utility. Every router has this. Your home router will have something similar. Okay. So in this case, you can give it an IP address 4.2.2.2, anything on the internet basically, and it will ping it, right? As you see here, right? So it's giving you the results of whether it's able to ping and reach that IP address or not. Now, what is ping basically doing is it's running an operating system command. It's running the actual operating system command of ping. Okay. What can, if you're lucky or unlucky, if I can call it that, you might be able to exploit a remote code execution vulnerability on your home router by passing additional parameters to the IP address field over here. For example, in addition to the IP address, I'm passing a couple of ampersands followed by PWD, right? In Linux world, PWD stands for present working directory. Okay. So what I'm hoping I'll get back is the results of not just the ping, but also the actual present working directory where this ping is being run from. And I can actually see over here /var/www/light-httpd, right? Just giving you an example. This is an exercise for all of you to try if you're at home or have access to such a router. And if it has such a page where you can run pings from, see if you're able to do some sort of remote code execution. Trust me, many of the routers out there have some vulnerability like this or the other. Now, this is an example of remote code execution. What is the remote code that was executed? It was PWD. It's actually very innocuous, not harmful at all, right? All I'm doing is understanding the directory. But what else can I do? Can I actually read some files? Can I list all the files? There are different Linux commands to do all of this. And if you're familiar with Linux, you can do that. Like for example, you could do ls to list the files. You could do cat to read files. Or you can do other commands actually to write files as well, if you wanted to in the system. So that is the concept of remote code execution. So let's look at, again, an example. I showed you a home router. You all can go and try it. But we're going to look at another challenge and see how you might be able to try out remote code execution. Okay. So here's the challenge that we're doing. It's CAAS. Quite simple. It says Cause as a service. Now, interesting thing is it's actually giving me a file here. And let me share that application. So you can see it. So I'll just download this file. There seems to be some hint here, right? So in this index.js file. So this is that index.js file. Okay. Looks quite complicated. And to me this is very complicated as well, because I'm not familiar with this language. But what it is some sort of JavaScript based on the name index.js JavaScript. And in this case, this is a flavor of JavaScript called Express.js. Okay. Don't worry too much about the format itself, but basically you're trying to find a vulnerability in this code is what this challenge is saying. Okay. So we have index.js. Let's also go to the website. Okay. Cause. I've accessed the website. What does this website say? Cause as a service. Make a request to the following URL to Cause your message. Okay. Blah, 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 HTTPS, etc., etc. I'm just going to copy it, paste it, and do hello. Okay. So this is what the website does. So it's an ASCII drawing of a cow that is saying hello. Basically, whatever you print here, it's going to say hello. So if you say bye, it's going to say bye. So whatever you print here, any random strings or text, it's going to do the same thing. Okay. So this is what the website is doing. Okay. But what you're looking to do is understand how is this vulnerable, and that's where the JavaScript file has been given. What it is doing exactly is with whatever you're passing as the message, it is calling this script, which is user games Cause, and it is passing what you sent in the message. Okay, and that is how it is rendering this ASCII diagram over here with whatever you're sending. Okay, just like I showed you in the screenshot. Okay, sorry, not the internet router use case. Let me go back. I'm going to do exactly the same thing. I'm just going to do 2 ampersands and PWD. Okay, literally the same thing on this website as well. And let's see what happens. Okay, so I'm just going to test and add PWD. Let's see what happens. Aha, you see it? You get more now. So it's actually executing the command that comes after test as well. So I said PWD, it's telling me that this is running within this folder called /app. Okay, can I list what's in this folder? Command for that is ls. Yes, I can. I can see some Docker file, some text files, bunch of JSON files, etc. So if I wanted to read a file, I could do cat Docker file. So this is the Docker file, right? So in addition to all of that, it's actually executing. This is remote code execution. This is actually executing commands on the server, exploiting a vulnerability. So the objective of the challenge obviously is get to the flag, and you see the flag here, and obviously it's misspelled. So we can actually look at the contents of the flag as well and do falg.txt. And this is the flag, right, to actually solve the challenge. So again, this is a very, very basic example of remote code execution. But the surprising thing, like I said, is this is not very uncommon still, right? Like I said, your home routers potentially maybe try it out. If it is, you might have, a vulnerability that you can report to whoever the vendor is of your router, right? So this is remote code execution. Okay, I'm just going to take a pause because we looked at a couple more examples. We looked at local file inclusion and remote code execution. Just want to see if there's any questions I do see a few questions.
Prabhan, there are several questions.
Yeah.
One of the question is, how can we defend from a session hijacking attack? Do we need to encrypt them using a different method?
Okay. So if I heard the question correctly, Kaushik, that was how can you defend from a session hijack or a session
Defend
elevation
from
attack?
a session hijacking attack. Yeah.
Right. Yeah, exactly. So the answer is actually in the question itself, which was using encryption. So cookies use encryption and what we call signing as a concept. Basically, no one can break the encryption to actually read what's in the cookie. Even if someone can, you can't actually modify it and make the server trust the new cookie that you're sending. And that is the concept of signing the cookie. Okay. Again, do read those two terms up. Again, I'm not going to go into the details of what encryption and signing is. The next set of sessions that you will have next week are cryptography, where they will be talking a little bit about what encryption is, what signing is, and all of that. So there you will understand a little bit more about what that means. But the answer to the question is that, right? Encryption and signing to make sure that no one can read it, but even if they read it, no one can modify it and fool the server. Okay. So I see
Another
some
question is,
question, right? Most recent one is, where is this PWD getting executed on which system exactly? Okay. So Akshit, I hope you're asking about this challenge. Where is this getting executed? Like PWD over here. This is getting executed on the server that hosts this challenge. And in the case of the router,
he's asking about router ping.
The router ping. Yeah, I figured so.
Yeah.
So if you're asking about the router ping, the PWD is getting executed on the router, wherever the web server is running. That is where remote command, remember the words in the slide, it says remote command execution, right? Let me go back to the PPT real quick. It's remote command execution, right? So you're executing commands on the remote end of this connection, which is the web server. So all of these commands are getting executed on the remote server. Okay, we'll take one more question. What is the difference between remote code execution
and command injection?
Okay. Well, that's a very, very good question, Amit. I'm glad you asked that, because that is the perfect segue to the next section that we're going to look at, which is going to look at injections. Okay. So hold on to your horse a little bit, Amit. We'll come to that answer, right? We'll come to that question specifically and answer that. Then there's how to encrypt the cookies is another question. There are many ways that you can encrypt cookies. You could use encryption algorithms that are available, such as AES, or any other, popular encryption algorithms that are available there. You could design your own encryption algorithm, but probably don't, because unless you are a really, really strong cryptography expert, it's very likely that the encryption algorithm you are designing is going to be broken by someone. So mostly you'll pick, encryption algorithms that are out there, and there are free ones available in any operating system to use, which are extremely secure to use. Okay, so moving on, for the want of time, we'll go into the last set of techniques that we're going to talk about in this section, which is injection-based attacks. Okay, we looked at this. To injections. Now this picture brings back some memories of getting those vaccinations. Now all of us have received that and probably had painful shoulders for a long time, but it was necessary to get those. But talking about web penetration testing as well, people don't like injections, especially those that are running the web server itself. So injection attacks, what are they? Okay, the concept of injection attacks is to be able to exploit web servers by injecting an operating system command through an HTTP request. So to the question that I think Ankit asked, yes, this is very similar to remote code execution. Command injection and remote code execution, you could call them the same thing. Okay. Only difference is, in the case of injection, you're actually writing something in most cases to the operating system, but not necessarily, right? It could be anything. So if you look at both of them, they are very similar. And as it says on the slide here, right? So it is very, very, very similar to remote code execution. But injection can go beyond just command execution. Okay, there could be different kinds of injections as well, especially when you're working with external services. Remember, when we spoke about the server architecture, we spoke about other services such as APIs, such as session management, such as SQL databases. injections can go into those external services as well, right? And not just on remote code execution. So yes, RC is similar to command injection, but injection goes beyond just command injection. And what we're going to look at in the next few slides is the concept of SQL injection. Okay. Now, why we're talking about SQL injection? Before we look at why we're talking about SQL injection, let's look at what is SQL, right? Generally, if you ask people what is SQL, people will probably tell you SQL is a database. That is actually a misnomer, right? A misunderstanding by most people. It has been taken to mean a database, but SQL basically is a kind of language, structured query language used by databases or used by users to actually query databases, right? That will probably be a more accurate way of saying it. So SQL is a kind of language, right? It's sort of like a scripting language. So databases that use SQL in order to communicate with them are called SQL-based databases. So you have MySQL and other kinds of SQL databases available out there, right? So SQL is actually not a database. SQL is a language, right? And they have a very specific structure that they follow. So let's look at the structure that they have, right? SQL databases that are based on SQL have this kind of structure. So generally there is a server where the database is hosted. Then you have the actual database instance as well, right? Within that server. Within the database, you have different kinds of tables, right? And each of those tables hold different kinds of data. And we'll look at an example shortly. And within the tables, you have rows and columns. Rows are basically individual entries, and columns define what are the various fields that are stored in that table. So this is a generic structure in most cases that any SQL-based database actually follows. And when you're talking about SQL as a language, the query format is generally of this nature. Some of you have probably seen this and are familiar with this, but for some of you, this may be new. This is how it works. And there's a very famous meme called Bobby Tables. And maybe I'll just Google search and show that to you. But that is a very famous meme talking about SQL injection. But let's talk about the query syntax again. Okay. What you have first is what data you're looking for from the database. So select is the verb, and you're telling what kind of data you want to select. In this case, it is SID or SID and the S name. That is basically referring to the columns in the database table. Where do you want this data from? That is the next part of the query. From this thing called students, and this is referring to the table. So from the students table, get me the SID and S name, and optionally, you can actually specify a filter as well. In this case, the filter is, I want these values only if the SID is equal to 1122. Very, very basic example of a SQL query, right? SQL is generally pronounced as SQL, okay? So you have what do you need, from where, and what are the filters you want. Those are the three things. And select basically selects the columns, from says the table, and where will say basically the filter based on the rows, right? Where the value is set to a particular thing. So let's look at a sample SQL server. I will have to share another application, I think. Let me bring that over. And here we go. You should be seeing my Chrome browser now. Okay. This is an online playground for an SQL server. This is not my SQL server. You go to this website, you will get this as well. Okay. But this is an online playground to really play around with SQL queries in different formats. Okay. So what it is telling you is there is this database called demo. Remember, we are logged into a server, but within the server, you have a database. The database is called demo. And within the demo database, you have a bunch of different tables. You have an employees table, you have a departments table, you have a customers table, etc., etc., etc. And each of those tables have their own columns and rows. You can actually see the number of rows. Right? So how do you actually see what columns are there in a table? Simple. Select select star from employees. Now, star is a special character, special keyword. What star is saying basically is get me everything from this table called employees. So let's execute that query. And now you can see what's in the employees table. So obviously it has 10 rows. And in the employees table, the columns are the EMP underscore ID, presumably the employee ID. You have EMP underscore name, the name of the employee, the date they were hired, the salary they get, and the department ID they belong to. So you see all of the columns from this employee table, right? Similarly, we can do any table. Let's say departments. You see another table called departments. This is a much simpler table. It only has the department ID and the department name. So you have customers, similar, right? So you have customer, customer ID, their address, the city, etc., right? So now, like I said, you can filter as well. So let's say select star from, we said employees, right? And you can filter typo, where we saw one of the columns was salary. So I'm just going to say where salary is greater than 4,000. Okay. So now instead of 10 rows, I'm only getting 3, 4, 5, 6, 7, 9 rows, right? If I change this to, let's say 5,000, 5,000, I get even lesser rows, right? This is how you can filter SQL queries. Okay. You can also select specific columns, like I said. So instead of getting all of the columns, I might just want, let's say, the name and the hiring date. So now you see that while the table has 10 columns or 7 columns or whatever, I can be selective in what kind of data I get back. So I'm only getting the name and the hire date. So this is not a SQL training, right? You will have other trainings and videos on YouTube if you go and search. This is just meant to introduce you to what SQL is, okay? Because not all of you might have been familiar with SQL. So why do we care about SQL injection? Now, the interesting thing about SQL injection is that this has been around as an attack technique for 25 years, right? This was very first time this was reported was way back in 1998, right? Now we are in 2023. So 25 years, SQL injection has existed, and not only has it existed, it is still a very, very common vulnerability that exists in databases or on web servers. So SQL is a very common kind of database that web servers interact with, and there are oftentimes many vulnerabilities that happen because of this. In fact, you go search online, a lot of the recent breaches that have happened are because of some sort of database related vulnerability and potentially SQL injection as well. I think most recently, if I'm not mistaken, there was one company that provided file transfer services, and they had a SQL injection bug, which led to a lot of their customers' private data being exposed. Yeah, Arav, I think, has put that in the chat. Move It was a company that had a SQL injection, based exploit just like a week ago. So still today, there is, huge prevalence for SQL injection. A lot of people still fall prey to it. So it's very important to be familiarized with SQL injection. Now, why do we care about SQL servers? Because SQL servers contain a lot of, private and critical information. The example we just showed you, it is very common for companies to have, their employee names, employee salaries, their hire date, customer addresses, customer PAN card and Aadhaar names, and all of that potentially stored in a SQL database. So if you get access to that, attackers can do a lot with it, right? You sometimes actually have usernames and passwords that are stored in SQL databases. And if you get access to that, you have a treasure trove of information, right? You get all the users' passwords by doing that. And that's why SQL continues to be a very, big part of the attack surface that attackers actually go towards even today. So, and how does SQL injection actually happen? SQL injection happens when the user input in the browser is passed on to the SQL query without proper sanitization or validation. So you saw a bunch of examples previously, right? So you generally have web pages which have, forms that you'll fill up. It'll ask you for a username and password. It might ask you, let's say in Amazon, you go up there, you search for a product, right? You search for shoes or phones or, TVs. That will probably be making some sort of query to a database. And if that data is not clearly sanitized before passing on to the SQL server, you run into SQL injection-based vulnerability. So there are some techniques, right? And these techniques are well documented, okay? First job generally in SQL injection is you first need to know that the server is actually using a SQL-based server in the background. So how do you do that? Is by injecting errors, right? How do you inject errors in a SQL query? By adding special characters such as comma or a quote or a colon or a semicolon, right? Any of those will inject some sort of a query, inject some sort of an error in the SQL syntax. Okay, so here's an example. Let's say, now you won't always know this, right? In a web server, this is the SQL query that has been executed. Select ID first name last name from authors, where first name equal to whatever the user is giving as input. So this user input is coming from a browser, right? So you are supplying the user input from the browser, and the web server is making this SQL query. Example, if the user input is Ravi, this is how the query is formatted. Select ID first name last name from authors, where first name equal to Ravi. Now you as a user don't know SQL is being used in the background. You just know that you send something called Ravi and you're getting back some data back. Now, how do you actually detect whether there is SQL being used? Injecting special characters. For instance, instead of Ravi, I put RAV followed by a quote and then I. So you see what happens in the query here. You see select ID first name last name from authors, where first name equal to RAV with a quote followed by I with another quote. You see a problem here, right? Previous query, you only had one open quote, one closed quote. But now you have three quotes. It's an odd number of quotes. So SQL obviously will throw you an error, something like this. This is just for illustration's sake, right? You have an error in your SQL syntax. And sometimes that either is shown in the browser directly, or if you open the browser inspector and look at the console, you will get an error in the console returned. So this is how you detect whether the server is actually talking to a SQL-based database in the background or not. You inject an artificial error by adding special characters in your query. Okay, let's say you found out that there is SQL server that's being used. What can you do to actually exploit it? One of the tips, this is not the only way to exploit it, this is one of the first ways to exploit it, is by adding conditions that always become true, right? Again, let's look at the same example we had, right? Select ID, first name, last name from authors. This is a filter. So you want to select these columns from the table authors, and you specify a filter where the user input is provided, okay? But you can satisfy the filter condition by adding some specific data such as A equal to A, okay? So again, this is a sample example that I showed you. Now, if let's say your user input on the browser was, this is what you're entering on the browser, Ravi followed by quotes, and then or open quotes A, close quotes equal to open quotes A, that's it. You're stopping over here. This is the query that you're sending. Now, if you look at the SQL query that the server will send, the filter looks like where first name equal to Ravi or A equals A. Now, pay close attention to just the filter, right? Either you're looking for the first name Ravi or you're looking for the condition that A equals A. Obviously, the condition that A equals A is always going to be true. That means you'll get all the data from this table, right? So this is one of the ways in which you can exploit a injection vulnerability. And there are many such ways. In fact, if you just go to this website, OWASP, Open Web, I'll just show that to you. It's called OWASP, and you do SQL injection. And this is an open source community. You will look at different ways in which you see here. All of these are examples telling you how you can actually exploit a SQL-based server. There are lots of different examples available and a lot of documents that you can read as well, right? So I've just given you one example for want of time. I know we are getting towards the end and we will have one last challenge based on the example that we just showed. But the idea is you need to read more and be more familiar with it. And when you're working on, let's say, the CTF challenges, you come online, come to websites like this, you will get to see a lot more such examples. Okay. So coming back to the last example of the day, we're going to this tutorial academy called Portsfigure. I don't know how many of you know what Portsfigure is, but Portsfigure is the company that has built Burp Suite. Okay. So they actually are a company that's into web penetration testing, and they have a lot of practice labs for various kinds of things that I just showed you, including cookies, remote code execution, local file inclusion, directory traversal, SQL-based attacks. They have a lot of practice labs for you to actually do. And I'm just going to show you one such lab. And the idea is you, after the session, can go here, sign up with a free account, and try any of these labs. Okay. So this is the lab. It says the lab contains a SQL injection vulnerability in the login function. To solve the lab, perform a SQL injection that logs into the application as the administrator user. Okay. So there is a solution. We're not going to look at it, but I'm just going to open the lab really quick. Seems to be taking time. There we go. So this is the web server, right? Now the objective is you need to log in as the user administrator. Okay. So how do you log in? My account, probably. Yeah. So this is where you need to log in. Let's try the same one that we did previously. So ideally you would have to give a user and a password. Okay. I'm just giving some random things. Never. So there you see invalid username or password. So it obviously needs administrator, and I'm just going to do some other password. Now you could spend a lot of time trying to figure out, what the password is, and you can brute force it. But the objective here is you're using some kind of SQL injection, right? So if you think about what the query will be, right? I'll just show you sample query. This is using SQL to log in the user. So the SQL query will be something like this: select username, comma, password from a table called users, where username equal to and password equals password. Okay. So in that server, this is probably the background SQL query that is being sent. Okay. Something like this. You can assume that this is what is happening. Right? Select username and password from users, where username equal to what you supply as the username and password equal to what you supply as the password. Okay. Now, how can you break this? Like I said in the previous this thing, you can actually make the condition always true. And how you can do that is go back to the PowerPoint, which is here. We'll try something like this, right? Administrator or A equals A. Let's try that. In fact, I had done this previously, so you will actually see that there. There is administrator or A equals A, okay? And some random password, login. There, logged in. Your username is administrator. So just a simple example again. Like I said, there are many tips and tricks available. There's a lot of online, like I said, SQL injection has been around for 25 years, and there are a lot of different tips and tricks available to perform SQL injection attacks. And you can go try out these labs, read some of these documents, or just search online, and you'll find many, many tips and tricks to actually inject, or extract data from SQL-based database. Okay, so that brings us to the end. Again, like I said, the objective here was to introduce you to a lot of these concepts and give you resources where you can go and learn and do more. Two resources that I introduced you to right now over the past couple of sessions, including Karthik, were obviously using Burp Suite as a tool and all the tools that you introduced. But basically, for more practice, use the Pico Gym, which is here, play.picoctf.org/practice. You can take a screenshot of this or just Google search for Pico Gym. Or you have Portsfigure with a bunch of labs on web security. Try out all the labs that are there. Most of them are simple, give you a lot of good practice to get you ready to play not just the CTF, but also going forward in your careers. Okay. So with that, we come to an end, and I'll just see if there's any other questions.
Yeah, Prabhan, there are several questions.
Yeah, so thank you, Prapanch. And I would now we'd move on to the Q&A section. So Mr. Kaushik will moderate the Q&A. Also, all the participants who have posted their questions in the Q&A section, please remain attentive as Prapanch will be answering your questions.
Thank you, Abhishek. Yeah, the question is SQL injection is kind of RCE.
So the question is SQL injection kind of remote code execution? The answer is no.
Yeah.
You're not really executing a code. What you're executing is actually a SQL query and tricking the database into giving you more data. Remote code execution is generally where you're actually executing code on the web server where the service is running, and you're actually extracting data out of that server. So there is a difference between what RCE is, remote code execution, and what SQL injection is.
Does multi-factor authentication prevent RCE, remote code execution?
Okay, so the question is, does multi-factor authentication prevent remote code execution?
Yeah.
Well, if you think about it, what problem does multi-factor authentication solve? Right? Multi-factor authentication came into existence because people's passwords are easily guessed, or they are easily leaked based on SQL injection style attacks, etc. Right? So when people's passwords are easily available, anyone can use anyone's username and password and log into any website. Now, multi-factor authentication was introduced to address this kind of problem, so that even if you have access to my password right now, you won't be able to access my Google account because it will ask you to maybe enter a password on your phone or send a code to your mobile through SMS, and you have to enter that code. So multi-factor authentication is meant to solve that problem, right? It will not really address remote code execution, right? So remote code execution is a different class of vulnerability and different kind of exploit altogether. They both are different. Multi-factor authentication exists for a different purpose and not for remote code execution.
Okay. Is it safe to save username and password in browser?
So the question is it safe to save username and password in the browser? It's a very tricky question, because that means it's not just browser, right? Is it safe to save your username and password anywhere? Is probably the question, right? Browser, probably not, but yeah, even I do save some of my passwords in the browser. I can't say that I'm not guilty of it. But generally it is okay if it is not a very sensitive password, right? Like if it's your banking password, please don't, right? If it's your critical email password, please don't, right? Try to remember them if possible. If not, use an offline password store utility. There are many such that are available. LastPass, and I think OnePass or something, and there are many such other softwares that are available where you can actually store a copy of that in an encrypted manner in your laptop, which is away from your browser. That is generally better. But the important thing is, if that is cloud-based storage, that is still not safe. It has to be locally stored. There was a vulnerability or an exploit, if I'm not mistaken, with one such password store software company, where a lot of users saved password that was saved on the cloud was exposed. So it was not in clear text, but even then it was exposed. So saving your password anywhere, it is not guaranteeing safety unless it's in your mind. So it is generally okay, but probably not recommended.
Yes. What are the ways in which SQL injection attacks can be prevented?
So what are the ways in which SQL injection attacks can be prevented? I'm glad you're thinking about prevention, whoever asked the question, because a lot of people are generally excited by, let's attack servers, let me try attack. But the world can't just run on attacks, right? There's a large group of people that are actually working on preventing attacks. Like both me and Karthik are on that side of the business, right? We are not attackers by the day, but we are actually defenders by the day. And there are many various ways available in which you can prevent SQL injection attacks. There are actually utilities available with the backend technology that you're using for your web server, right? Main objective is you need to be careful when you're taking the user input and passing it over to a SQL query. You need to sanitize it and look for any special characters or things of that nature. You have to filter it to only match the specific thing that you are expecting, right? If it is a username, it should only contain let's say strings and numbers possibly, not special characters. Or you have something called prepared or composed queries, which can also be used. But all of this is going into a little bit more detail about it. But main objective is you need to sanitize the input from where the user sends it before you pass it over to the SQL query.
Okay. How cookies can be encrypted for safety?
Okay, how cookies can be encrypted for safety? Yeah, like I said, many ways in which you can do that. You can use freely available encryption algorithms. Google has its own called Tink, if I'm not mistaken. You have many other such encryption algorithms that are available for free. Better to use those. Just don't design your own, because that's probably not the best way to do it. Yep.
Okay. Does direct object reference cause SQL injection?
Does direct object reference cause SQL injection? I'll be honest, I'll have to understand a little bit more about what direct object references mean. I'm not quite sure exactly what you mean by direct object reference.
Yes.
So maybe I can
It's
answer that.
incomplete question.
Yeah.
That's all, Prapanch.
Okay.
Okay.
All right. Well, with that, thanks a lot for your time. I'll pass this back to Abhishek to close out the session. Appreciate your time.
Yeah, so thank you very much, Prapanch, for this session. I think I'm pretty sure that you kept all the participants on their toes, and those who have, made it through the whole session have gone through all the exercises, I hope, and as much of simulation and as much of practice all the participants can go through and also score well in the assessments, they would be enhancing their chances towards one of those prizes at the end of the CTF. So I'd like to thank Mr. Prapanch Ramamurthy, Principal Engineer, Cisco Systems India Private Limited, for this excellent session on web security and penetration testing. The tempo was set by his colleague, Mr. Karthik Shivakumar, and he has only taken it further ahead. So thank you, Prapanch. I think you can drop off now, and we'll make the announcement regarding the assessment in just a minute.